In this class, we will learn about the concept of resistivity from the chapter Electricity, class 10. So when it comes to the definition of resistivity, it is very similar to the resistance. That here you can see that resistivity is an intrinsic material property. Okay, I will tell you what is this intrinsic material property mean. So that measures how strongly a material opposes the flow of electric current, right? So resistance also, we have learned that it is an electrical property which opposes the flow of electric current. Resistivity is also opposes the flow of electric current. Coming to the major difference between resistance and resistivity is, as resistance is an extrinsic property, here the resistivity is an intrinsic property. Yes, in the next slide, I will tell you what is this intrinsic material property. Okay. And coming to the formula, we already seen after the law of resistance, right? What is that? R is equals to rho into L by A, right? So if you take this L by A to the LHS, what you will get? That is rho is equals to R into A by L, right? So this is the formula or a mathematical expression for resistivity. And when it comes to the units, you know that unit of, here I will write, the unit of resistance is taken as ohm, whereas the unit of area is considered meter square by unit of length is meter. So that meter and square get cancelled. Finally, what you got? Ohm-meter, ohm-meter. So coming to the SI unit of resistivity, the SI unit of resistivity is ohm-meter. Here you can see that, right? It is the representation of the unit. Done? Yes. And now we see here the factors that affects the resistivity. As I told you, the resistivity is an intrinsic property. Here, intrinsic property is nothing but which does not depends on the dimensional physical quantities, okay, like length of the resistor and area of cross section of the resistor. That means the resistivity, it won't depend upon the length of the resistor and it won't depend upon the area of cross section of the resistor. It only depends upon two factors. What are that? Nature of the material of the resistor and temperature of the resistor. So as resistivity doesn't depend upon this dimensional physical quantities, we call this as intrinsic property of a material. That's the meaning of that, what we have seen in the definition. I hope you understand the thing. So these are the two factors that affects the resistivity: nature of the material of the resistor and temperature of the resistor. Done? Okay. And next, based on this property, that is resistivity, materials are classified into three. What are they? Conductors, semiconductors, and insulators. You know that conductors are nothing but materials which allow the electricity to pass through, whereas insulators are the materials which does not allow the electric current to pass through. Coming to the semiconductors, semiconductors will partially allow the electric current to pass through them. Okay, that is the meaning of semiconductors. Coming to the conductors, if you see the resistivity value of conductors, its typical range of conductors will be 10 power minus 8 ohm meter to 10 power minus 6 ohm meter. That means their resistivity is too low so that they can conduct the electricity. And coming to the semiconductors, okay, their resistivity ranges approximately from 10 power minus 6 ohm meter to 10 power 6 ohm meter. You can see here the resistivity value of semiconductors are larger than the value of resistivity of conductors, right? Yes, so that they partially allow the electric current to pass through them. Coming to the insulators, these they won't allow the electric current, right? So that the resistivity value will be larger than the semiconductors and conductors. You can see here the resistivity value of insulators ranges from 10 power 8 ohm meter to 10 power 18 ohm meter or even higher. So that insulators will have high resistivity. They opposes the flow of electricity so that they won't conduct the electricity because of high resistivity value. Okay. Yes. This is all about resistivity, and we see have two numericals related to this resistivity. Coming to the question one, here you can see that calculate the resistivity of a material with resistance 3 ohms. What they have given? Resistance 3 ohms and cross-sectional area and length of 25 centimeter square and 10 centimeter respectively. That means the area of cross section is taken as 25 centimeter square. Okay. And length is given. Before that, I just want to convert this area of cross section into meters. 25 into centi means you can take 10 power minus 2 meters square. Okay. Now, coming to the length is given 10 centimeters. The length of the material is given 10 centimeters. 10 centimeters, right? I want to convert this into meters so that you know that 0.1 meter, 10 centimeters equals to 0.1 meter. Now we got formula to find the resistivity. We need to calculate the resistivity of this material, right? So that resistivity is equals to R into A by L. What is R here? 3 into what is area of cross section? 25 into 10 power minus 2. Okay, meter square. Let me take this here is equals to 3 ohms. Okay, done by what is length? 0.1 meter. Okay, now the meter and square will get cancelled. Fine. 3 into 25, you will get 75 into 10 power minus 2 by 0.1. I can write 1 into 10 power minus 1. Shall I? Yes, we can. So 75 into 10 power minus 2. If you take this 10 power minus 1 to the numerator, you will get 10 power 1. That is 10. Right? Finally, what you will get? Here you can further write likewise. 75 into 10 power minus 2 into 10. 10 power minus 1. Okay, finally what you will get here? 7 point, okay, 5 ohm meter. 7.5 ohm meter is the resistivity, right? Yes. Now coming to the question 2. The wire's length and area are 0.3 meters and 1.0 meter square. That is, the length of the wire is given 0.3 meters and its area of cross section is 1 meter square, okay, respectively. Calculate the resistivity of that wire if its resistance is 5 ohms. That is, resistance of the wire is 5 ohms. What you need to calculate? You need to calculate the resistivity. So the same formula again, resistivity is equals to R into A by L, right? So what is R here? 5. What is area? 5 ohms, right? What is the area of cross section? 1 meter square by, what is length? 0.3 meters. Meter and square get cancelled. 5 into 1, 5 by 0.3 ohm meter. Okay. Further, if I want to remove out this decimal, what I will do? Into 10 by 10, right? So that what you will get? 5 by 3. Sorry, 50 by 3. Now, if you further solve it, 3 ones are, so 2 will get remainder 20. 3 6 are 18. Again, you will get 6. Again, you will get 6. It's a recurring one, right? So that you can stop with this. So what is the resistivity of this wire? 16.66 ohm meter. Okay.